Like to welcome you all to our travel show for today. We'll be taking a look at some old Untold Earth mini documentaries about America and just showcasing how beautiful our country is. So this is the actual link, so that way you can view any of these videos too, as well. And they have some other series on PBS's website. So they have some kids programming or adults programming. They have In Her Nature. This one looks really cool to watch. Those are about 30 minutes. Backyard Nature, Wild Hope, Animal IQ, discovering the true intelligence of animals. You can learn about zoology and botany just with PBS's website. So I encourage us to take a look. So we're going to be taking a look at some of these clips here. So everything from the Northern Lights to Yellowstone to volcanoes to this place called the Antelope Canyon. So I'm really excited to showcase these videos for us today. We're going to start off in the Redwood Forest. It's sacred to the Yurok tribe and a scientific frontier for the study of vast biodiversity that exists nowhere else on Earth. So this is season one, episode one of this documentary. So I hope we all enjoy and learn something new, and let's chat.
There's something really magical about redwood forests.
Do y'all know about redwood trees? This is in California, the national and state parks. But they look beautiful, don't they?
Hanging out in a tree that you know
Yeah,
is 2,000 years
pretty
old
cool.
and kind of stoically standing in one place, you kind of have to
Look at
experience
those
to be able to
trees. Have
explain.
you ever stood beneath a
There's three
really
things that
tall
kill
tree?
trees. There's bugs,
Beautiful.
there's fire, and there's disease. And this tree is adapted to
Enjoy
fight all three of those.
where we are tall.
It's the tallest tree in the world. There are species up there that only exist in the canopy,
Oh my God,
and
look
you
at
don't
that.
find them anywhere else in the world.
The size alone makes you feel humble. And I think any time humans
Say that again.
can make a
Okay, look
connection
at those
that
massive
makes them feel humble, it fascinates us.
The redwoods predate our existence on this planet by 135 million years. Today, what's left of them can be found on a narrow strip along the northern Pacific coast. These mighty giants survived the age of the dinosaurs. Can they survive us?
Can you believe there are trees as old as the dinosaurs? Mm.
Yeah.
We are on the banks of Roy, the Klamath River. I'm a part of the Yurok tribe. Our home is surrounded by geet, the old-growth redwoods. We've been here as long as they've been here. We respect them because they're living beings of our family. The story that has been handed down from Yurok people and talks about the redwoods as guardians. They watched out for us as a people.
You come to this forest, you feel the calming presence coming from these ancient giant trees who are just saying, it's okay. We survived for hundreds and thousands of years, and so can you. This is the place the redwoods grow the best and the biggest for two reasons. One, this coastal zone of California along the cold Pacific Ocean gets a lot of rains. It needs a lot of water. You can't grow a big tree without a lot of water. And then the summer, that cold water meets the warm air and creates a lot of fog.
There's physiological complications
Oh wow, fog also helps the trees. I never thought about fog in that way, have you?
No,
with pulling
not
water.
really.
Fogs help the trees. So when it's foggy outside, the trees are getting really hydrated.
300 feet up against gravity. The trees snag the fog moisture out of the air. And then the fog water, it can drip down the tree and they can absorb water through their leaves, through their bark. And then they can also absorb water crazily. They make roots in their crowns, like hundreds of feet above the forest floor, that are growing into these crazy wet epiphyte mats and presumably uptaking water.
What?
Wow.
Epiphyte mats. So it's like roots that are hundreds of
Hmm.
feet in the air.
Hmm.
Ferns, mosses, liverworts, lichens, or lichens. Wow. I never
They're
thought of
not just a
roots in any other place besides the ground.
species that takes water like most of our tree species do, but they capture cold water that helps benefit all of our salmonid species and all of our species on the coast and inland as well.
Look at
The
those, look
redwood
at those
forest is like a giant
Hmm.
superorganism because they interweave their roots and hold each other up like true friends. If one part of their friendship circle is having a little trouble, they actually can send them nutrients and water from another more healthier tree. Being so tall,
You know, trees can
Yeah, I
talk to
read
each
that.
other. Yeah, trees can talk to each other.
Hmm.
Plants can talk to each other. Flowers can talk to each other. You read that, Gracie?
Yeah. And my mom and they taught us that the plants and the grass and everything communicates. I've been taught that all my life.
hmm They sure do.
They have their language, the way they
Yeah.
communicate. Hmm.
Uh-huh. They have their own brains. It's
Hmm.
just in their roots.
Hmm.
they're kind of vulnerable, like a skyscraper, to being pushed over in a big windstorm. The only thing that really saves them from falling over is having this interconnected root system.
Yeah, all the trees are connected with each other. I mean that's so amazing. What do y'all think of the redwood trees in California and how old they are and how they are so vital to the community and the world?
Next time I go to California, I'm going to seek and I definitely find one. You know what I mean? I might have seen them going along the highways and stuff, but I didn't know all of that. So when I go, I'm going to seek and I get somebody to point some out to me or take me in an area where they are.
Yeah, the
Yeah,
redwood forest.
yeah, I've read about it,
Redwood
but I don't remember
forest.
seeing it.
But what part of California isn't it? Oops.
Yeah, I was in Los Angeles, so I don't know, if they are in that part or not.
Yeah, so redwood forest, it's in of course it's California. It's on the let's see. Let's go to the map. It says there's a place called Crescent City. Let me zoom out. So there's San Francisco. Oh, it's all the way up there.
Hmm.
It's borders Oregon. Oh wow, look, Shasta, Trinity. Look at all these forest areas. Shasta Trinity National Forest, Trinity National Forest. Where are these spots? Says Eureka, McKinleyville, Trinidad. Wow, there's a Humboldt Redwood State Park, Six Rivers National Forest. So there's a lot of trees right here.
Hmm.
Okay. Lady Bird Johnson, Grove Trail. Lady Bird. Oh, this is Oric, California. Wow. Hope you all enjoy learning about redwood trees. Um, have y'all ever heard of Antelope Canyon before?
Mm-mm. No, I don't think so.
Me neither. So this might be the most visited and photographed slot canyon in the world. So if you see this preview, I don't know if this looks familiar, but maybe. Formed millions of years ago and is revered as a spiritual site for the Navajo Nation, the origins of this geologic wonder are as fascinating as its beauty is renowned. Antelope Canyon. Mm.
These are the home of the winds. That whole canyon would be considered the Nishchabaran, breathing holes of the earth where the winds reside down in there.
This is the actual
All of these shapes are from water that's very turbulent,
this is Arizona. Wow.
spinning the sand, spinning the pebbles. Just awesome power.
There's a lot more than just the beautiful photos.
Just look. What do y'all think? Look at this picture.
Wow.
Doesn't it look like coral or something?
Mm.
It looks like AI. Yeah.
It's
And
a
I'm
real
sure the water did that millions of years ago, shaped it like that.
mm-hmm.
Yeah.
Mm-hmm.
Beautiful.
Mm. Mm. Does that picture, this
Awesome power.
I mean, oh my gosh, look at how the light comes through
Mm-hmm.
on this side right here, and then this little spot. And then it looks blue or purple.
Purple.
There's a lot more than just the beautiful photos.
Oh, that's so beautiful. Look at that. Look, this looks like, I don't know. This looks so heavenly right here.
Mm-hmm.
There's history behind the people here, the culture that we share, the respect we have with Mother Nature, the respect that we have with the land.
You might recognize Antelope Canyon from your desktop wallpaper or your social media
Right.
feed.
Oh,
but
that's
even
where on the computer.
Okay.
I remember some of the desktop wallpapers that come by default. They're like these crazy shapes, but those are real photos.
though it's one of the most photographed slot canyons in the world, almost every single one of those photos is out of date. Antelope Canyon is in a perpetual state of flux, constantly being altered by relentless
Never
forces
looks
of
the
nature. So what does it mean to preserve something that is defined by its impermanence?
Wow.
We are on the western part of the Navajo Reservation, which is one of the largest Indian reservations in the United States. This here is Antelope Valley. You can see Lachi'i Rock there, Navajo Mountain. So we're on the border of Utah and Arizona. Since this has been relatively new and popular with, you'd say, Instagram and social media, there has been an influx of people wanting to come experience these canyons.
Antelope Canyon probably receive about over 1 million people a year. We see all different sorts from all over the world. As one of our very first tour groups that we brought through here told me that this should be the 8th wonder of the world, and I believe it.
So if we think about the formation process of these canyons, they're fundamentally carved by monsoon flash floods. We're here above Glen Canyon, which actually has been incised only in the last 250,000 years. So we get a giant wave of water come down. It can appear as a sudden wall of water. People that hear a flash flood go by often describe whatever the loudest noise that they're familiar with, that's what they choose to describe it. So the water is very turbulent, transporting cobble-sized boulders that are bashing the bed. So then a slot canyon is very narrow and very deep.
Saw them walking through that little tiny canyon.
No, I don't imagine that.
Yeah, but you saw them in the video that they were walking through this thing.
So the key thing that tells you is the attack by the water is mostly focused at the bottom. It must cut 100 times faster at the bottom than it erodes the sides.
Oh my gosh, look.
There's a lot you can see here about the process of how these canyons are cut. There's often waterfalls coming out on all sides. And you can see that action on the side here with all these shadows behind every one of the Moki marbles, as this is being blasted by sort of everyday flows, transporting some sand that's sandblasting the side. But there's also much more powerful effects going on. These boulders that you see at the bottom here are actually transported in these floods. And
Look how huge they are.
Wow.
Can you believe water can move objects that huge? I mean, those must be some, like they said, the strongest flash floods, the loudest noise you ever heard. That's what they described it as.
See at the bottom here are actually transported in these floods. And if you look back in here, then you can see all sorts of scales of the turbulence that will occur. Vortices spinning through here. See this very sharp edge right here? This is a contact between...
Like that looks man-made. A little bit to me. But the water did that.
Water out here flowing this way and swirling back around in here, taking the sediment probably up to almost fist size, grinding against the edge and carving this out over time and driving that erosion by a abrasion process.
Dangerous.
It's pretty hard for water to get through such a narrow slot. You don't want to be anywhere near it during one of those events, though. I have to say I would love to witness one.
Yes, my blessing.
My family has been in this area for generations.
Oh, look at those. Look at those horses. I love horses.
So we would take our sheep and go into those slot canyons, and this was our playground, is what it was.
Oh, look.
My goodness.
Navajo, I mean, there are, I mean, it's this is just amazing to look at.
The one thing that we always got told is you take care of the land and you always be spiritual.
Every breath of air
I'm gonna take that in my life. I'm gonna always take care of the land.
Mm-hmm.
Where we take is sacred. We're surrounded
Every breath of air we take is sacred. I'm gonna take that too.
by and given life through the winds. It flows through our body. How do we carry that wind until we take our last breath and our spirit continues on and follows the holy people. So when we enter into their home like this, we pay respect to them with their songs and a small prayer.
As a person, you do your offerings. That way, the canyon knows you, the air knows you, the land knows who you are.
We do know that it's changing because we have been through several major rainstorms and we see the power of water. We've seen Anasazi markings in the canyons and they're high up. So you know that as it goes, it has carved deeper and deeper.
As the stream is going down through here during a monsoon season, sometimes the water level is about 15 to 20 feet high running through these canyons. As the flash flood goes through here, it digs down.
Look at the color of it looks almost purple or in this beautiful orange.
And sometimes it'll replace all the silica at the bottom, so it changes. Every storm is going to change these canyons.
There are many canyons here in northern Arizona, southern Utah, that have an amazing history of filling up with tens of meters of sediment and then getting re-excavated as climate has changed back and forth over tens of thousands of years. So long term, it's going to keep moving upstream. But over the short term, it will fill up and cut back down. So on an annual basis, you'll find changes.
The more that it erodes, who knows what history and fossils and things we'll discover.
Mm-hmm.
What do y'all think about these canyons? The Antelope Canyon.
Alex, we tried to go there last year on our trip to Zion and in Grand Canyon. It's right on the way. And then what stopped us was it's pretty expensive to go in there. You have to hire guides that have permits into the Navajo Nation.
Yeah. It's a spiritual place. It's a sacred place.
Yeah, you might get lost if you go on your own.
Oh, I wouldn't want to go on my own at all.
No, me. I'm not going with the tour guide. I'm not going.
Okay. So we were in California, then we're in Arizona. Let's move all across the world. Well, to America still, but Kalau in Hawaii. Let's look at the volcano that won't stop erupting. Can you imagine a volcano never stopping erupting?
Kukulu kapahu kapua kaleo heala hele heala muku no kanelo kana.
Kane and Kanalo. I've heard of that before. Beatles' law of
Pelehunuamea. She who creates and destroys. She is the volcano goddess. She's a living force on this landscape.
Kilauea is one of the most active volcanoes on Earth.
It's a puzzling, complicated system that only makes itself more complicated by how active it is.
Without volcanoes, we wouldn't have Hawaii. Volcanoes are the foundation of our islands.
For the last 40 years, Kilauea has been in a state of near constant eruption, providing researchers with a uniquely reliable setting to study one of our planets.
Can you imagine being right next to an active volcano? Look at him. Isn't it, the people that discover these things for us are so amazing.
Uniquely reliable setting to study one of our planet's most unpredictable and destructive forces. In a time of climate panic and tangible ecological destruction, what can we learn about the survival of our planet from one of the harshest environments on Earth?
Look at that. Look at that grass. Look how green it is. Hawaii Volcanoes National Park.
Hawaii Volcanoes National Park is 350,000 acres, which stretches from the coast all the way up to 14,000 feet at the summit of Mauna Loa.
We are in the Kilauea area, and Kilauea means to spew lava.
And so even if you've never been here, but you understand that's what the name means, you know what to expect.
Kilauea is a little bit different from sort of the stereotypical pointy cone volcano because it's called a shield volcano. Shield volcanoes.
A shield volcano. I've never heard of that. Have you all heard of a shield volcano before?
Mm-mm.
Mm.
No.
Form when lava is extra runny and can go really far from the vent where it comes out. Right now it's not erupting, but from 1983 to 2018, that was 35 years of near continuous eruption. And then in 2018, we had a huge eruption and we had what's called caldera collapse. The summit of Kilauea in chunks sort of collapsed in on itself and dropped down about 500 meters, which is about as tall as the Empire.
Oh, look at it. Oh,
Wow.
Let me go back. Let me go back. At least see how it caved in on itself, y'all.
And we had what's called caldera collapse.
Caldera
The summit
collapse.
of Kilauea in chunks sort of collapsed in on itself and dropped down about 500 meters, which is about as tall as the Empire State Building.
In 2018, large sections of this road actually fell into the caldera. The fact that it just one day decided to open up and swallow a huge section of road, and then the parts that are still remain, throw around like little, tinker toys. Talk about the, kind of the awe-inspiring.
Look. The road stops. Oh my gosh.
Force that the volcano has.
Now that we're in 2023, we've had 3 eruptions in 1 year so far, and now we're waiting for the next one. Volcanic gases are one of the main reasons we have volcanic eruptions in the first place. So if you think about a bottle of soda and those explosions that you get if you shake it up too much, those are all driven by those gas bubbles dissolved in the soda. Eruptions are driven by gas bubbles dissolved in magma. We measure sulfur dioxide and carbon dioxide, and mostly the sulfur dioxide comes out during eruptions, but the carbon dioxide comes out before eruptions. So if we can track that, that can help give us clues about whether or not the volcano is refilling with magma. We want to make sure
Isn't it amazing that they know how to do that?
we're watching the gases and all of the other data all over the volcano, because it's not just the summit that's active. Working on an active volcano like Kilauea and always monitoring it is almost like being a doctor, because the land here really does seem almost alive.
If you thought about a volcano as a living, breathing entity and body, gravity is the body mass index. So I use gravity meters, or gravimeters, to study variations in the acceleration of gravity, or the force of gravity, that are measurable on the surface, but that are being caused by changes in the volcanic system. And gravimetry is the only way to extract that data. It's the only way we have of measuring changes in mass. That's pretty good. It's pretty stable. These instruments can measure 1/1 billionth of the force gravity that we feel every day. So unbelievably precise.
1 out of 1 billion.
And can I use that as a precursory signal for
So
warning?
accurate.
Can I say, hey, look, we saw a great change in gravity right now, and then 20 minutes later the volcano erupted? It's still cutting edge, so the question is I still don't know, but we're trying. The idea is to get to a measurement that is solely unique and is something that tells us about how much actual magma is moving into or out of the system.
Pele's law of heat. It is taboo to approach volcanically active lands.
The chants are hundreds and thousands of years of empirical data. Our ancestors saw an eruption and they noted how the ground opens up. They noted how the flow came, if it was a fast-moving flow and a slow-moving flow. And we've been fortunate lately to have a partnership with Hawaii Volcanoes National Park and Hawaii Observatories, because I think we're telling the same story. We're telling it through chant and narrative, and they're telling it through their scientific record. For a long time, our language and our culture was seen as just fable. And now that we show that our chants and our stories are not just cute little fairy tales, there's value in it, there's lessons in it that we can extract from all of those chants and stories.
What do y'all think of the volcanoes?
Fear. I see that hot lava and stuff rolling. I don't think about getting close to that at all.
I don't think so. And they have much fire there.
35 years of continuous eruption. Oh my gosh.
So much.
I went there with my wife right when it started to erupt. We weren't even married yet. And it would actually reach the sea, and we were watching it explode when the magma entered into the sea. It had just started erupting. It was actually no, it was erupting for a couple. It was 1990 when we were there. I think it started in 88.
Oh my gosh, Lou, thank you for sharing that.
Did he say that without the eruptions, there would be no Hawaii Island?
Yeah, there were the islands. Without the volcanoes, we would not have the islands of all the islands, the tropical islands, those are created because of volcanoes and eruptions. Yes.
Wow.
It's just amazing to think about.
It is.
My cat didn't think much of the volcano, but she liked the chanting.
Oh,
she came running.
But that's so true. And things that are passed down, and we shouldn't discount them and think of them as fables.
Right.
I like that part that they shared. So moving from Hawaii, now going to one of course, Yellowstone National Park. NASA has an interest in it. There's underwater exists a diverse system of microbes which scientists have been studying for decades and have been a catalyst for life-changing discoveries. Could these microbes be the key to discovering life on other planets? Yellowstone National Park. You're gonna
That water coming out of Grand Prismatic somewhere around 89 degrees centigrade. It's hard to imagine that life doesn't just exist in these hot springs. It thrives in these hot springs. It's adapted specifically to these conditions in these hot springs. If we can understand the kind of conditions that support microbiology and its origins on Earth, that will help narrow our search for life on other planets.
The Grand Prismatic Spring is the most recognizable thermal feature of Yellowstone National Park. While many of its mesmerizing qualities are easy to see, some of its most fascinating features are invisible to the naked eye. Below the bubbling surface exists a diverse system of microbes which scientists have been studying for decades and have been the catalyst for life-changing scientific discoveries, including the basis of the PCR test. Now scientists are asking
PCR test.
An even bigger question. Could these microbes be the key to discovering life on other planets?
So Yellowstone National Park was the first national park established in the United States. What makes Yellowstone special is the concentration and diversity of hydrothermal features and geysers. So there are more geysers in Yellowstone than the rest of the world combined.
It's a volcano, but it's not a cone type or a shield type volcano. It's underground. It's a huge...
So even we're back home in the States, there are still volcanoes here in the States.
magma chamber, and it's the heat source.
Essentially, it's like Hawaii. Hotspot volcanism, except for the fact that you've got this continental crust over the top of it.
The water source is just normal surface water, rain, snow, so forth.
So you have this huge amount of water that's essentially cooling that magma chamber. When it cools, that water rises to the surface and forms these hydrothermal systems. So Grand Prismatic Spring is the largest hot spring in all of Yellowstone. A truly magnificent example of hot springs. Typically, what the geologists tell us is that you find hydrothermal areas at the edges of lava flows. This hot water's coming up from depth. It wants to take the path of least resistance, which is not in the middle of a lava flow that's crystallized. It's at the peripheries. So these lava flows essentially squeeze these hydrothermal fluids into pathways of least resistance, which is the lower geyser basin, which is the midway geyser basin where we find Grand Prismatic, and the upper geyser basin, which is where we find places like Old Faithful.
Upper, middle, and lower. The path of least resistance. That's how we get the geysers and the hot springs.
It's about 300 feet in diameter. It has a discharge of 560 gallons of hot water per minute, which is rather astonishing if you think about it. At the point where the hot water wells up out of the ground, the water temperature is about 183 degrees.
That's hot. 100 boiling.
In 1993 and again in 1995, I had the privilege of going out on Grand Prismatic Spring in a specially designed thermal boat. It looks precarious, isn't that?
You'd be scared. It's real hot. That water's super hot. I'd be scared.
I wouldn't go out.
Not even for $1 million? No.
I don't think so.
That is a specialized thermal boat. Wow.
Picture, but I don't remember it feeling precarious. No need to worry about life preservers. I guess one thought that I had.
You don't need life preserve. You go in that water, that'll be the last time you go in that water.
If the boat somehow did tip over or something went wrong, that the agony wouldn't last very long.
Oh no.
That's Grand Prismatic is one of the most colorful springs there is. Period. And what is it
that beautiful? That blue color. Blue's my favorite color, so I'm a little biased, but goodness gracious.
Causes that deep blue color. The bedrock here in Yellowstone is really silica rich. So these fluids come out saturated in silica. Now this silica refracts sunlight, blue sunlight, and that's why you see it as blue.
Because of the silica at the bottom. This looks like a whole rainbow right here.
It does. And as that water fans out towards the margins of that spring, it's cooling off. And then all of a sudden you see this transition in color to orange, to yellow, to green. And essentially what you're looking at there is a transition between different microbial groups, all
Right, that silica, what's the green? What microbes is that? Yellow. The different colors are due to different organisms and stuff.
Synthetic that make different pigments to harvest sunlight.
There were many thermal researchers along the way, but the one that really springs to my mind is Dr. Thomas Brock. And in or about 1966, he is the person who really got into studying what he called thermophilic microorganisms and life at high temperatures.
Thermo, heat, philic, attracted to high organisms. Life that lives at high temperatures.
NASA funds my research in particular because of their interest in understanding life's origins. All of the life that you can see with your naked eye is ultimately supported by the sun. This life is very different. These organisms live off chemical energy, and it wasn't until about 2.8 billion years ago before life figured out how to harvest energy from the sun. So for the first billion years of life's history on Earth, it was dependent on chemical energy. Well,
I never thought about it that way. The first million years is full of chemical energy. Let's hear that again.
Live off chemical energy. And it wasn't until about 2.8 billion years ago before life figured out how to harvest energy from the sun.
From the sun, 2.8. So from this whole time, Earth formed 4.5, chemical evolution, Earth's crust was stabilizing, chemical energy. But finally, around 2.8 billion years ago, that's when life figured out how to take energy from the sun. So look at that. And then all the way over here, this is dinosaurs and this is mammals. So look at that. Dinosaurs is all the way over here. So you have all this other bit of history.
So for the first billion years of life's history on Earth, it was dependent on chemical energy. Well, hydrothermal systems are unique in the fact that they bring that chemical energy to the surface. NASA's very interested in studying extremophiles because if you understood the environment that led to the emergence of life on Earth, then you could say, well, if everything else is the same on another planet, I should expect to find life there too. And so if we understand how life originated on Earth, we can use that to also narrow our search for life on another planet. One of the most phenomenal discoveries was of a microorganism called Thermus aquaticus. Thermus aquaticus was isolated by Tom Brock back in the 1960s. And after he isolated this organism, other researchers purified an enzyme out of this organism called Taq polymerase. That's the basis of PCR.
We know what PCR tests, right? They're used to detect infectious diseases like COVID-19, influenza. They use it by finding active viral RNA. So without the hot springs and Yellowstone, we may not be able, that's amazing.
We just made our way through the COVID pandemic. If you had a rapid PCR test, the basis of that test has its roots in the hot springs of Yellowstone.
So if you took a COVID test, you got to think Yellowstone. It's amazing. Oh my gosh. What do y'all think about Yellowstone? We've talked about it before. We had a whole session dedicated to it. But how do y'all feel about it now? There's more life than meets the eye. That's about
I love the guys who when they be talking about Old Faithful and stuff like that. But I'd like to read about it. I'm not necessarily worried about going to see it.
And then if you study at Yellowstone, then that'll help you determine if there's life on other planets.
Yes. Because of those things using that chemical energy. Before we were able to harness the sun. So I mean, there's a lot of life before that. So if we find the same organisms on the other planets, then there could be life there as well.
Right.
The only time I've ever been to Yellowstone, I was in high school, and I told my parents that I was going to go up live in Detroit. I said, I'm going to be up north, staying at my friend's cottage. And me and my buddy hitchhiked to the West Coast. My parents didn't even know it, and and unfortunately, I took a picture. In the background was a geyser. And I told my dad was looking at my pictures when I got back, and I said, "Oh yeah, Dad, that geyser is in Upper Michigan. Yeah, oh yeah." Now I was some dumb kid. I didn't realize that there's no geysers anywhere in Michigan. There's no geysers anywhere in the United States except Yellowstone.
Oh my goodness!
So the jig was up. The jig was up.
Where's the fish?
Wasn't that an amazing story, Lou? We could use Yellowstone to help us find life on other planets. That's pretty amazing.
Yep.
Let's go to your side of the country, Lou. Let's go to Florida's wetlands.
All right.
Let's learn about the carnivorous pitcher plants.
Ooh.
Why these bugs live inside plants that eat them. Hope y'all enjoy.
I love pitcher plants because of their beauty.
Look at those. Those are pitcher plants. Have y'all heard of pitcher plants before?
No.
Yeah.
The Sarracenia.
Oh, look.
Someone at the Botanical Gardens, if I'm not mistaken.
Oh, really? Man, look at these white ones. Oh my gosh, they're so pretty. Look how it goes from green to white.
Pitcher plants are the most complex and amazing carnivorous plant. The way that they operate and have digestive enzymes and attract the pollinators and their...
No, it's not like the corpse flower. It kind of is, though, if you know what the corpse flower is, or not like a Venus flytrap, but I love these kind of plants.
Food to the plant. It's very clever.
They turn the tables on insects. Think about this leaf, this pitcher. It's actually a death trap for almost anything that would enter it. But one of the things that makes pitcher plants so fascinating is that there is a certain set of organisms that actually circumvent the death trap, and they instead live within pitchers.
The pitcher, a prolific carnivorous plant, is blurring the lines between predator and ally. Why do these beautiful and vicious plants have mercy on some and not others?
They're very beautiful. Blackwater. You know the spot, Lewis, says Blackwater River State Forest.
This area, Blackwater in Northwest Florida, is one of the most diverse botanical
Longleaf pine chapter president. Wow, Florida Native Plant Society.
areas in the United States.
What also draws me in and makes my love affair with pitcher plants even more enduring are the symbioses. The mystery of what are these organisms, how do they interact with the plants, how do they survive?
The pitcher plants are in flower right now, and that is quite spectacular, and they're only in flower in the spring. And this is a pitcher plant right here. I'm looking for insects. Here's one right here that the sepals are drying up. You see them right here? This is Sarracenia leucophila, known as the white top pitcher plants. And we're looking inside.
I'll see that little insect right there, and then there's the insects right there.
Of the pitcher and seeing insects that are stuck in there.
All carnivorous plants have four things in common: attracting prey, capturing prey, digesting prey, and then finally absorbing nutrients from the prey. Prey items within...
Sounds like humans. No.
Pitcher plants are quite diverse. And they range from mostly insects, but they also range through spiders and slugs and other crawling invertebrates.
Wow, spiders, and can you imagine a plant eating a spider or a slug? Or even, I don't know, this grasshopper-esque looking thing, or oh my gosh, crawling.
If it's got enough nerve to come crawling up there, he'll show him what he'll do for him.
Okay. Okay.
Virtually any organism that's small and gets within a pitcher plant is doomed. But there's a really interesting set of exceptions to that. Why be symbiotic? Well, it appears that that mass of decomposing prey, because it's around for a while within the pitcher, that abundance of decomposing organic matter, along with the abundant bacteria that feed upon that mass, those provide opportunities. That's actually very energy rich for any organism that can capitalize on it. There's a food web inside this pitcher. Once a death trap, now a micro ecosystem.
That's amazing to think about. Once a death trap, now a micro ecosystem inside of a plant.
And the decomposing prey is the base of the food chain.
Look at that. Y'all see that stuff?
Some of these symbionts are what we call obligately symbiotic. They live nowhere else but the interiors of pitcher plants. There is an entire genus of mites that lives only within the pitchers of the Western Hemisphere pitcher plants. And it's present in every species of pitcher plant that we've checked so far. We have living Sarraceniopus mites from within a pitcher that I removed when we were in the Nolan greenhouses. And you can sense, as I focus on this, the mite is moving, and it's moving very, very slowly right there through the prey remains. Another group of interesting symbionts in Sarracenia pitcher plants are the sarcophagid flies. And what these do as larvae, they're living within the plants and they're eating the prey soon after it's captured. We also get a midge, another aquatic insect, as a larva.
A midge? I've never heard of a midge before.
Prey soon after it's captured. We also get a midge, another aquatic insect, as a larva. And researchers documented that when these insect larvae are present, moving through the prey remains, the levels of nutrients like nitrogen are elevated relative to when the symbiotic larvae are absent. One of the great questions is, what effect do the symbionts have on the plants, if any? In most cases, it's not yet been studied, but in a couple of cases, biologists did study the effects of the aquatic midge and the mosquito larvae, and they found that these symbionts are beneficial to the plants by decomposing the prey more rapidly. So they concluded.
So all of the mites, and they get to eat, and the plant still gets to eat, and even faster, because the mites, they help decompose the material faster.
That these symbionts are actually mutualists. Mutualists are members of a symbiosis in which each half, the symbiont and the host, benefit. Not all symbionts are beneficial. So the caterpillars of these Exira moths get inside.
Look at that caterpillar. Isn't nature amazing? Look at the spots. Like, this is like nature's beauty, nature's woven yarn. It looks like yarn. It looks like fabric.
Pitchers, they eat the interior tissues of the pitchers, and in the process, they've destroyed the pitcher. So it's actually a parasite.
And this one over here, this is a typical of the moth. It starts in the larva, it starts eating the pitcher from the inside out.
You can think of the mutualists as having a buddy, your best friend. You help each other. Your friend is there in times of need. And on the other hand, there are these moth larvae, the caterpillars, that get in there and destroy. So that would be a false friend, somebody that when you first met, you thought was a friend, but it ends up you want to be done with that person.
Look what them things did. They ate that thing up.
A lot of people think that because pitcher plants are popular and beautiful, that virtually everything is known about them, but that is far from the truth. As biologists learn more and more, we began to realize that it's quite likely that the symbionts themselves are playing a major role in decomposition and digestion. You can imagine experiments in which we have pitchers grown in a sterile environment with no symbionts, and those with symbionts, and learning about the possible benefits. But we have yet to solve those mysteries. We do not know. That work remains to be completed.
Well, what do y'all think of some bugs and this pitcher plants and how beautiful they are, but how the species are benefiting each other?
Yeah, I think that these biologists work for probably universities and have fellowships and grants to study this. And I think we have to study nature and study the plants. So it helps us with medicine and food. So I bet they work for universities, or if they don't, they work for the federal government, one or the other.
Yes, yes, yes. I love it. I love it. Thank you,
Alice,
for
can you hear me? Can you?
Yes, yes, Miss Hill. What do you think of the video?
Oh, it was a reminder for me. In the cotton fields in South Carolina, we had boll weevils and we had caterpillars, and some of the caterpillars would sting you very, very bad.
You sure would.
Oh, well, yes, I know some of them are, caterpillars are venomous or poisonous. Yes.
Yeah.
So, yes, but they were eating those plants up in that video, weren't they?
Yep, yep.
They eat up the cotton also.
Yep. Boll weevils, they should have to spray for those bad boys.
I hope you all enjoyed all the videos. Again, we looked at the Redwoods Forest, we looked at Antelope Canyon, we looked at the volcanoes in Hawaii, we learned about the volcano and geysers in Yellowstone. We also took a look at these Florida plants. Last but not least, there is a place called Petrified Forest. What turned these ancient trees to stone? Can you believe tree turning into stone? I don't know. Let's see what goes on.
Petrified Forest National Park preserves
an important period in time, about 220 million years ago.
Oh.
An interesting time period because it's actually bracketed by two mass extinctions.
Petrified Forest National Park is probably one of the most underappreciated national parks in this part of the United States.
We really do have one of the largest concentrations of petrified wood.
Petrified wood. Have y'all heard of petrified wood before?
Wow. No, I heard of petrified forest, so that encompasses all of that.
Look at the trunks. I mean, they look like stone. They look like rock.
Here at the park, where you can really study how animals and plants change over time.
In places like petrified forest where climate change is preserved as a record in the rock, we have a standard that we can use to compare against changes that we're actually observing around us today.
Petrified Forest National Park is a time capsule filled with ancient trees that have crystallized over millions of years, essentially turning to stone.
It used to be a tree.
Wow.
What secrets do these fossilized ecosystems reveal about the prehistoric past? And how can they help predict the future of life on Earth?
Used to be a tree.
A tree.
Petrified Forest National Park is one of the most complete records of the end Triassic in the world. It is a really interesting area to study how species were recovering from a mass extinction and diversifying, and then dealing with challenges in the future.
There's no better place to see late Triassic rocks exposed in such completeness and in such glory.
Look, this looks so interesting.
At the start of the Triassic period, the area that we now call Arizona was on the leading edge of a supercontinent that we call Pangaea. This diagram here is what geologists call a stratigraphic column, and it is a graphic representation of the sequence of rocks that's exposed here at Petrified Forest National Park.
Isn't that amazing? Look, they have the whole map of the rocks. What's this? Lot's wife's bed, rainbow forest bed. Wow.
Representation of the sequence of rocks that's exposed here at Petrified Forest National Park. Most of this is the Chin-Lee Formation, which is the upper Triassic and all of the fossils that are associated with it, the magnificent Badlands topography that you get where these rocks are exposed at the surface.
Over 200 million years ago, this was a lush, tropical floodplain where massive trees thrived along rivers.
In Arizona. Can you believe how green it used to be?
When those trees fell and were buried under layers of sediment, groundwater rich in silica from volcanic ash seeped in, gradually replacing the wood with crystals of quartz, preserving the stunning logs we see today.
There's a similar process for how the wood is petrified to how the fossils are fossilized as well. So this is a trail that kind of winds through a bunch of these huge petrified logs that we have here.
Part of the permineralization process is certainly helped by abundant silica, and the volcanic ash is full of silica. We see a lot of evidence of volcanism in volcanic ashes in some of the rocks, and we see pebbles and cobbles, just little round pieces of rock that eroded out of those volcanoes, and we can see those here.
These plants and animals would die, become buried in water and sediment, and fossilized. They'd all be preserved together, kind of giving us a picture of the entire ecosystem. In order to find fossils, you need a certain set of conditions. So you need rocks of the right age, and you also need them to be exposed at the surface. Areas like petrified forest really are ideal to look for fossils, being in this desert landscape with badlands and monsoon rains and cycles that really bring in a lot of erosion. They're constantly exposing new fossils, constantly exposing new things that we can find.
the Triassic period ends where it does is because that is a time that's marked by a major mass extinction event. And the proximate cause of that mass extinction is said to be climate change. The climate change was probably triggered by atmospheric changes, carbon dioxide pulses that were brought about by the breakup of supercontinent Pangaea and the eruption of unusually large volumes of magma as lava at the surface, bringing with it these gases.
Various lines of evidence, including isotopes, tell us that conditions were getting warmer and drier over the course of the Triassic. And so it is a good area to kind of study how animals are responding to these climate events. We do see an extinction event at the end where only certain animals make it through. Species that are more specialized typically have a harder time during extinction events if they have a really specific environment that they live in or a specific food source.
What we're seeing today is much faster, much different from what nature has done, and we really can only attribute it to the activity of human beings through burning of fossil fuels, manufacture of cement, deforestation, and so on. What we find is that what's going on now is happening at a markedly greater rate than anything that we can discern in the geologic record, except for the very brief catastrophic events that have happened, like meteorite impacts, for example.
Animals that are tied to specific environments might have a harder time, like animals that are semi-aquatic and need both land and water. The oceans can also struggle through climate events, through ocean acidification. Really kind of just the species that are more generalized will likely be able to adapt more, and we'll start seeing specialists disappearing first.
If climate change that we see now is a purely natural event, it will be millions and millions of years, long past any of our lifetimes, but we're seeing things in our lifetimes. So we have to use...
Seeing things in our lifetimes now when it comes to climate change.
Use the outdoors, the rocks that we see, the national parks, everywhere that we can go and study rocks and deposits. We can learn from them about what is going on the planet today and what we can think might happen in the future.
There's a lot that we can learn from Earth's history. There's 4.6 billion years of Earth's history. There's so many past time periods, past extinction events that we can look back on and see how these animals did through different types of events and see how life recovered after, and really just is the best tool that we have to kind of make predictions moving forward.
Oh, well, that video right there, again, climate change, we see it, and we want to preserve our planet. Any thoughts on this video? How you feel about watching all the videos today? Do you feel more worldly? Do you feel like more interconnected? Especially when they talked about the volcanoes and the silica, and we learned about the silica at Yellowstone, and just how life is connected to each other. Any thoughts on the videos today?
I was thinking about that plant down off from the mall. I think is that the pitcher plant? They call it the corpse plant.
I think it's a type, but I do love that corpse flower, and it was just in bloom not too long ago.
Yes, that's what I heard. I was wondering about the connection, but I think these people who've been narrating these videos, Alex, I guess they study geological history or something.
They're but from universities. Okay, the corpse flower isn't a pitcher plant, but they're from different families. But the idea of them, yes, they're is kind of the same. But the corpse flower is its own thing.
Yes. Well, these have been all very, very interesting and very educational.
Alex, I learned about the pus caterpillar. I never knew there was a stinging caterpillar in the South.
Yeah.
But I did some research. It's called the pus caterpillar, and it's incredibly painful if you get stung by it.
Wow.
Oh, okay.
Yeah, it's a white fuzzy caterpillar. Is that the one that you all have seen? It's got a white hairy caterpillar, and underneath the hair is venomous spikes.
Wow.
Seen that one.
Is that the one you all are talking about? You got stung by?
No,
No,
this one
I'm
is in
not.
the cotton fields.
I'm
He's
not
Yeah,
sure.
looking.
It's this color. This is the one that actually eats the pitcher plant. This caterpillar right here.
but the one that stings human beings, someone brought up, was in the cotton fields, and my
Yeah,
research said it was called the pus caterpillar, and it's incredibly venomous.
yeah. I've seen
Yeah.
them. Yeah, yeah.
So please check out some of their other ones. Look, this one's about truffles, survival to the forest. This one's about the giant rock in the middle of a field at Devil's Tower, Bear's Lodge, the Northern Lights, cuttlefish. You can learn about Pando, which is an ancient tree in Utah, Louisiana's mega swamp, and hurricanes. And, and again, PBS, they have other series as well. Again, everything from Inner Nature to Backyard Nature, Wild Hope, Animal IQ. This one looks really interesting. Like baby penguins can navigate better than you. I mean, these are some great videos to watch. And I hope you all enjoyed today. Any last
Yeah, that
thoughts?
was fun.
What's what's the website, Alex? Again, what's the
Oh,
website?
yeah, sure. It's in the chat. It's just straight from PBS.
Okay.
And I love their programs. Again, I watch, PBS all the time, and I love
Mhm.
watching nature. And their website has a lot of resources. So again, if you want to look at full episodes, yeah, I mean full episodes of collections. Like if you want to learn about parenthood with animals, dogs in the wild, the Alps, born in the Rockies, and the ocean. If you want to learn about primates, super cats. There is no shortage of a wealth of information available to you. Thanks all so much for joining. Let's wish Lou a wonderful 4th of July. Any
Happy
other?
4th of
Everybody, oh my
July.
gosh,
Yes,
all of you.
yes.
Who's going to the
Thank-
fireworks downtown? Who's going?
Oh,
It's going to be too hot.
And
I
too
gotta try
late,
to walk
right?
from my patio.
I
well,
think it's going to go off at 11 o'clock at night. That's
yes, yeah,
crazy.
it's around
Yeah,
11
Well,
o'clock.
everything that man do is crazy.
I can see some of it when it goes real high from the patio. I'll look
So,
out there.
I can
well,
Why
see
in
the
the world
again,
would they
let's.
fireworks.
do that at 11 o'clock at
Well,
night?
again,
You got
it's
all these
hot. There's a lot
families
of
and kids who
it's a
want to
lot
see
of
it.
different things going on. So
Mhm.
let's just enjoy again being on this earth and celebrating. And again, let's all wish each other a wonderful 4th of July. And thank you, Lou, for hosting.
Happy 4th, everybody. Great
Happy
job,
4th.
Same to
Alex. Great
you.
show.
Bye.
Thank you
Thank
so much. That
you.
was great.
Appreciate you all. See you all at 1:30.
See you at
Okay.
May the fourth be with you.
May the 4th be with
once.
you.
Oh, God.